Hello students, this is Professor Mahajan MR. Welcome you all for online course Emerging Trends in Mechanical Engineering. The unit for discussion is Unit 2 Process Engineering. Course outcome. At the end of this course, students will be able to apply heat engineering principles in process boilers and waste heat recovery systems used in process industry. Unit outcome. At the end of this session, students will be able to state principles of ultra supercritical boilers. Agenda is concept of ultra supercritical boilers, key features of ultra supercritical boilers. Dear students, you have learned in last academic year generation of steam at constant pressure. Observe here there is a temperature enthalpy diagram and process A, B, C and D. This indicates steam generation at constant pressure. Let us say this pressure is 1 bar. Here BC indicates latent heat. Now let us carry out the same process at some higher pressures, say 10 bar. This will be indicated by process number 2. Observe at higher pressures latent heat requirements are reduced. Let us carry out this process of steam generation at 100 bar. Again latent heat will reduce. The process is represented by 0.3. This continues till critical point. After critical point, you will not observe any such distinct phase change, and the water will get converted to superheated steam with lesser amount of heat. Critical point of water is 221.3 bar and 647.14 degree Kelvin. Boilers working below critical point are called as subcritical boilers. Boilers working above the critical point are called as supercritical boilers. Let us discuss about efficiency of thermal power plant. Thermal efficiency of thermal power plant is ratio of amount of power produced by steam turbine to the rate of heat supplied to the boiler by burning of fuel like coal or gas. Say for 1000 megawatt plant with efficiency of 40% will require 4000 megawatt of heat to be supplied by burning of fuel. Using this 4000 megawatt value and by knowing calorific value of that particular fuel, we can determine the rate of consumption of fuel by that particular plant. When it comes to efficiency, pressure and temperature of steam entering the turbine matters. Higher the pressure and temperature, higher the efficiency and lower carbon dioxide emissions. Companies like GE are driving towards 50% of efficiency with use of advanced ultra supercritical technology boilers. Let us see some advantages and disadvantages of supercritical boilers. On advantages side, latent heat required is 0. Coal and ash handling is also low. Pollution like carbon dioxide, NOx, SOx becomes low. Overall efficiency may go beyond 45%. Surface heating area required in boilers also gets reduced. Startup time of these boilers is lesser than subcritical boilers. They have a lower water consumption, and also there is a great reduction in feed pump power requirement, as feed pump uses lot of power from the power generated by the power plant. On disadvantages side, weight of boiler increases, more corrosion because of the sulfidation as well as oxidation. Due to higher pressure, it need more supervision and maintenance, and also there are material limitations due to very high temperatures. So new materials are being tried for such boilers. Student can see here two images of supercritical boilers. One indicates pulverizers where coal is crushed to powder and it is supplied to burners. Burners are low NOx burners which maintain the temperature of flue gases in such a manner that NOx production will be reduced. According to few manufacturers, they have reduced NOx down to 9 ppm. Third number shows attemperators. These are placed in between superheater and steam turbine. They inject water in the path of steam so that the temperatures will be maintained in a desired range. Then there are some conventional parts like economizer, superheater, and reheater that already you have learned in subcritical boilers. SCR, selective catalytic reduction technique, is also available in subcritical boilers. Remember, ultra supercritical boilers use high temperature resistance materials like austenitic steel, which are having 18 to 25% of chromium. This is some actual scale of a typical supercritical boiler. Rankine cycle for supercritical boiler. Observe here temperature entropy diagram. There are two different cycles. Red color cycle is Rankine cycle for subcritical boiler power plant, and blue colored cycle is for supercritical boiler power plant. Observe 1, 2, 2A, 3, 4, 5, 6, 7, 1 is Rankine cycle for subcritical boiler indicated by red color. Let us see Rankine cycle for supercritical boiler. 1 to 2 is pumping the condensate from condenser pressure to boiler pressure. 2 to 3 dash is regeneration, that is preheating of water in say economizer. 3 dash to 4 dash is superheating. You can observe the pressure is around 240 bar. 4 dash to 5 dash is expansion of steam in high pressure steam turbine. So this will give you power output. 5 dash to 6 dash is reheating in reheater. So again temperature will be increased to 590 degrees centigrade as you can see in the sketch. 6 dash to 7 is expansion of steam in low pressure steam turbine, and 7 to 1 is again condensation just like previous process. Let us see some comparison of three different boilers based on various parameters. Subcritical boilers, they operate at pressures below 221 bar. Supercritical boilers operate from 221 to 250 bars. Ultra supercritical boilers USC operate above 250 bar. Future targets are 380 bar. Temperatures subcritical 566, supercritical 540 to 580 degrees centigrade, ultra supercritical above 580, and future targets are 720 degree centigrade. Also observe the trend of plant efficiency is also continuously increasing. We are talking about 40 to 44% of thermal efficiency of the plant with ultra supercritical boilers. Carbon emissions are also showing decreasing trend. Also, the power generation cost in rupees per kilowatt is also showing decreasing trends. These are the values taken from a certain source. This comparison is also from a 1000 megawatt coal plant from some western country. It is showing emissions in these three different types of boilers, and you can see may it is the sulfur dioxide, may it is the NOx, may it is the particulate matter, all expressed in kg per hour of operation, and they are indicating that the trend is decreasing from subcritical to ultra supercritical boilers. So in conclusion, we can say ultra supercritical boilers are giving lesser emissions amongst all these three types of boilers. This slide also shows typical comparison of different boilers like subcritical, supercritical, and ultra supercritical. This is taken from a literature of a company L&T having a plant in joint venture of capacity 700 megawatt using Indian coal with gross calorific value 3300 kilocalories per kg. There are various parameters on this particular column, and there are various boilers on this particular row. Findings will show the coal consumption is also decreasing as we move towards ultra supercritical boilers. Same trend can be seen for ash generation, for carbon dioxide generation, and for sulfur oxides generation. The conclusion is ultra supercritical boilers have lesser pollutions as well as lesser requirements of coal for a similar capacity power plant. These are two sketches from General Electric. These are two different boiler configurations. They are having the specifications claimed by GE are pressure 330 bar, temperature 650 to 670 degrees centigrade, fuels, coal, oil, gas, heavy residues, biomass, and other opportunity fuels. Typical power produced by the plant is 1350 megawatts. This left side is two pass PC boiler. PC stands for pulverized coal, and right side is a tower PC boiler. That's all. Thank you so much.